So that's the difference. And of course, if it went left, it'd be negative y squared. That's your first step. You know, see which one it looks like, because you can rule out two of your choices right off the bat. Now, the part we haven't really talked about yet is like the number in front of y. This one has 4, this one has 1/4. So to start with, your vertex at the origin, HK, is, that's 0, 0. Your general formula would be x minus h squared equal 4a and then y minus k. But in this case, hk is 0, 0, so we have x squared equal 4ay. The next thing you do for this one is notice this is going right 1 and up 4 in my case. And so that means we can say this is x and this is y. So we can say 1 squared equal 4a times y, which is 1/4. So that means 1 equal 4th of 4 is 1. And so in this case, a is 1. So then you go back to your formula and say x squared equal 4 times 1 times y, which is y, it's x squared equal 4y, which is that one. So the main idea, just like on some other things where you're trying to figure out your vertical stretch amount, is actually substitute in the ordered pair. Substitute in 1 comma 1/4 for x and y, and solve for a. Otherwise, you just like have to guess and check, and it's like, technically, I guess this one looks normal, so to speak, and 1/4 would be a little more narrow. No, it'd be a little more wide. It'd be a little more wide. Okay. I know you can't actually check your ordered pairs because the table's disabled. Now, I did want to mention, if you go to your function and then to your equation template, well, we don't know. Oh, I need to go to parabola. If you notice on here, these are all solved for y. So on the calculator, it's solved for y, not x squared. So you can't just say x squared equal here. On here, whoops. These are solved for y. So even though they have x squared in them, like for the top two, you're probably going to end up having to use standard form. Okay, so you could use equation template, standard form. So it's just like something x squared plus something x plus something. Now, like I said before, it's solved for y. You need to solve for y. Standard form. Okay, so if we solve for y, we have x squared equal 4y So x squared over 4 equal y. So you'd put 4 here, you'd put 0 here, and 0 here. And so there it is. And if we go to 1, well, it's not letting me get to the table. Oh, it should be x squared over 4. So I would need a 1/4 x squared. And so then you can kind of guess. I don't like kind of guessing, but you could do trace maybe and say what happened at 1/4. Well, 1/4 is kind of close to 0.3 because a fourth is 0.25. And so you could say it's about 0.02. So that's better than the other one. The second one, we would have to say, so let's see, this is for A. For this one, we'd say y equal 4x squared. And then you put your 0 here and 0 here. And so that was that red one that I did originally. You could see that when you go to 1, it's a pretty high number. So anyway, that's 2 ways to do the problem. To me, the most straightforward is to use your formula and plug in your formula. Okay, the next one is on this. Try to eliminate some choices. This one looks like y equal negative x squared, which means x squared equal negative y. So notice I just put my x squared on the left and then a negative y. Well, this has x squared and positive 4. This has y squared. This has x squared and a negative. This is y squared. This is y squared. This is x squared and a negative. And this is x squared and a positive. And this is y squared. So even though there's like 8 choices, you can rule out many right away. So then the next part is, this is your vertex, negative 5, 6. So we call that H and that K. And so it looks like on all of them, you're having x plus 5 squared negative something, and then y minus 6. Okay, well here I can see this is x minus 5 squared, which means right 5. Well, this one's vertex is 5, negative 6. So that's the opposite. And this is the one with vertex negative 5, 6. So that's what we want. So again, double check that, double check your vertex, and then you got it. Okay, so then this one, it says the graph is given, match the graph to the equation. This one opens left. And so this would look like x equal negative y squared, or you could say y squared equal negative x. It's going through the origin, so there's not that extra h and k, but we know it's going to be y squared equal a negative number. So now you're down to 2 choices. Now, the point given is the -4, -8. So this formula would look like y minus k squared equal -4a x minus h. Oh, actually, we can simplify that to just -4ax, because your vertex, again, is 0, 0. But if we use our point on the graph, we can say -8 squared equal -4a times -4. So this is 64 equal, this one times this one is 16a. And so then you divide, and so you get a is 4. And what I just noticed, is we have y squared equal -4ax, x is -4. Is that now we got to plug that into here, so y squared equal -4, and then we solved a was 4, and then you have your x. So that's y squared equal -16x. Like that. So basically we're plugging our point in, finding a, and it's not just 4x, it's, you got to plug in here, so -4 times 4 is -16. Now this one tells you some different information. It tells your focus and your vertex. If the focus is at 7, 0, I'm going to label that F. Remember, it opens inside, opens towards the focus. And so that means this one opens right. Our vertex is here at 0, 0. And so if it opens right, our formula is x equal y squared. Well, it looks like that. But your formula is x equal, let's see. Okay. We would need y minus k squared equal 4ax. Minus h. So this is really, with it, the vertex being 0, 0, it's simpler than you think. It's just y squared equal 4ax. And the a part is this distance, a equals 7. The distance a comes from the distance between the vertex and the focus. And so that means from 0 to 7. And so that's 7. So y squared equal 4 times 7x, which is 28x. And so that's why you get that answer. Now for the lattice rectum, the part we haven't really talked about yet in detail is the lattice rectum goes through the focus. This is lattice rectum. There's 2 points. There's, that one and that one. At any rate, it's going to be 7 comma number. Okay, so the 28 is the length of the lattice rectum. 28 is the length of the lattice rectum. And so then you just do 28 divided by 2 is 14. So you go 14 up and 14 down. So plus and minus 14. So this one's negative and this one's positive. Okay, now on this one, this looks like y equal x squared because it opens up. So that means it's y squared equal 4x. I did that wrong. X squared equal 4y. Okay, so basically if I say it looks like y equal x squared, we need the x squared first. So the x squared equal 4y. And this one tells you you have 5. And if you're going from 5 to 0, that means a is 5. One more time. X squared equal 4ay. Sorry about that. So that's x squared equal 4 times 5y. So that's how you get your 20y, which is right there. Now, that means your length of the lattice rectum is 20. Length of lattice rectum is 20. So then you need 20 over 2, which is 10. So that means at 10, it's 5, and at negative 10, whoops, that's 12. I wasn't looking carefully. This is 10, 5, and this is negative 10, 5. Our focus, by the way, was at 5. So the part that I wanted to emphasize this time is that your lattice rectum y value needs to be the same as the focus y value since it opens up. Or let me just say if opens up or down. If it opens left or right, it has to be the x value. But in this case, it opens up, so that 5, so think of that as like a little box. So 5 here, 5 here, 5 here. And because your number was 20, we divide that by 2 to get 10. So that's why it's 10, 5 and negative 10, 5. Okay, now on this one, they're telling you something different. They're talking about the directrix. So you're at 0, 0. You need to know if it's y equal a number, that means it's a horizontal line. And if it's 1/3, then that's above the x-axis, that means if you go 1/3 this way, which is at 0, negative 1/3, then it's going to open that direction. So that means it opens down. And whenever it opens down, we think y equal negative x squared, or you could say x squared equal negative 4ay. Now, in this case, our a is 1/3. So a is a distance. And so we say use the positive. So we say x squared equal negative 4 times 1/3 y. So that's x squared equal negative 4/3 y. Now, since your y value is negative 1/3 for your focus, your lattice rectum is also going to use negative 1/3. So your focus y value is negative 1/3. So your lattice rectum y value is negative 1/3. So that's why these are negative 1/3. So the next part is we plug that in here. So if you have x squared equal negative 4/3 times negative 1/3, then you have x squared equal 4/9. Then you got to take your square root, and so x is plus and minus 2/3. And so that's why it's 2/3 for the right point and negative 2/3 for the left point. And it was this graph. Okay, so for number 10, this time we have a vertex not at the origin. So your vertex is at 6, negative 2. This one opens down. So it's like y equal negative x squared. Excuse me. But it's really like x squared equal negative 4ay. Just kind of like working through the process. That's if it's at 0, 0. Here it's at 6, negative 2. So since the vertex is at 6, negative 2, then you go x minus 6 squared equal negative 4a, and then y plus 2. So the y plus 2 is because it's down 2. This one means it's right 6. So then your next part is you got to see that from negative 2 to negative 5, that's a distance of 3. So a equal 3. I guess if you want to, you can mark this. It's counting by 4s, so here's 6. This is where the 6, negative 2 is. And so then we go 3 units down, so you get to negative 5. So this one was your vertex, and this was your focus. So what we said before is for your lattice rectum uses the y value of the vertex. And so that's why I have it marked up here. That -5 is used for your latus rectum. And then we basically see that your part here has -12. And so if this is just another way to check it. If 4a equal -12, then a is -3, which was like down there. So we go back to here and say if our equation was x minus 6 squared equal -12, y plus 2, and we know our y value is -5, then this is x minus 6 squared equal -12, -5 plus 2. So that's x minus 6 squared equal -12 times -3. That means x minus 6 squared is 36. So you take your square root of both sides, and so you get x minus 6 equal plus and minus 6. So then you say 6 plus and minus 6. So 6 minus 6 is 0, 6 plus 6 is 12. That makes it 0, 5, and 12, -5, and 12, -5. So that's how you figure that out. Basically, we knew our y value, and so then you plug it in. Okay, now this one opens left, and so that'd be like a x equal -y squared thing, or you could say y squared equal -x. We're not at the origin, and so it's really y minus k squared equal -4a, and then x minus h. In this case, we have -5, -6, and so that makes it plus 6 squared equal -4a, and then x plus 5. Oh, I didn't read that direction very good. You know your focus and directrix this time. You don't know your vertex. Well, what do we know about it? We know that the vertex is in the middle. The vertex is in the middle of the focus and directrix. So if this one's at -5, -6, and this one is at +1 for that whole line, this particular point is 1, -6, then you can say -5 plus 1. Wait, we really want the middle. So that's it's -2. It's -4 over 2, which is -2. So the vertex is -2, negative 6. So that means in your formula, we go y plus 6 squared equal negative 4a x plus 2. Now, if you go from negative 5 to negative 2, that a distance is 3, since you're going from negative 5 to negative 2. So that means y plus 6 squared equal negative 4 times 3, and then x plus 2. So that's how you get 12. So negative 12, x plus 2. So that's how come it's that one. And then for this one, your lattice rectum, it's going to have the same x value. As the focus. And so that's negative 5. And then that means this is negative 5, 0, and negative 5, negative 12. Because you say the length of the lattice rectum equal negative 12, well, really 12, and then you divide that by 2, so 12 over 2 is 6, and so you start at your vertex, which is negative 2, negative 6, and then you want to go up 6, so that's negative 2, 0, and you want to go down 6, and so that's negative 2, negative 12. So that's how you get it. Okay, this one, we know our vertex is the origin. It doesn't actually spell that out, but you know there's no movement. It's not going right or left. And we also know we have a formula, 4a equal negative 20. So you divide by 4, so a is negative 5. We also know this is like y equal negative x squared, or you could say x squared equal negative 4ay. Our a is negative 5. Well, remember before we said it had to be positive. So it's the absolute value of this. So that's 5. Well, it's 5 units down, basically. So x squared equal negative 4, and then 5y. So that's x squared equal negative 20y, which is that. So that means your focus is at 0, negative 5. See, we already knew that our formula was negative, so we didn't have to change our a to be negative. We already knew this distance is 5. So there's your focus. And so if that's 5 units, then the other one's also 5 units. And so that's the y equal 5. So if you know this is 5, then that's 5 up. And so that's y equal 5. Now, you know if it's y equal is a horizontal line, if it's x equal, it's a vertical line. Okay, now this one is opening right. And so that's like an x equal y squared thing. And so that's y squared equal 4ax. But in this case, you already know your formula. And so this means -2 for y and -2 for x. So that's your vertex. And so that'd be this one right there. And so now for your focus, if we know that 4a is equal to 12, then a is equal to 3. And so you start at your vertex point, which is -2. You go right 3, 1, 2, 3 units. So -2 plus 3 is 1. And so then you're at 1, -2. And then if you went 3 units this way, then you got to go 3 units this way to -5. So this is x equal -5. So again, if that distance is 3, then this distance is 3. Then on this one, it's like x equal y squared. So that's y squared equal 4ax. This one, the vertex is not at 0, 0. So we have to take it like this. And if your vertex is at 0, -2, that's your h, that's your k. And so it's y minus a -2, so y plus 2 squared equal 4a x minus 0. So that's really just y plus 2 squared equal 4ax. Now, on this one, it looks like you have a 1. This one you have a -1. It's not the y minus 2 things. What we know is your A unit is 1. So we know that it's got to be positive. And this one was negative. And so that's it. So then for this one, we know your vertex is at 4, -1. And so let's just get into it. Y minus k squared equal 4a x minus h. This is your h, this is your k. And so we need the one with plus and a positive. And then this is like y equal x squared, and so x squared equal 4ay. And your vertex is at 0, -4. So that's x minus h squared equal 4a y minus k. So that's x minus 0 squared equal 4a, and then y plus 4. So that's just x squared equal 4a y plus 4. And so we have a positive and a negative. Now we're going up 1 unit. And so that's how come you get that. So if you can visualize it, your length of the lattice rectum equal 8. So half of it was 4. So half is 4. And so you do x squared equal 4 times 4, y plus 4. And so x squared equals 16, y plus 4. I think I forgot to do that on part of them. So here's your 16, that's the answer. On this one, we just had a difference of 1, and so that was pretty straightforward. Yeah. Okay. So this part you probably can figure out on your own just based on positives and negatives, but that's your entire explanation of it. Okay, hope that helps.